Nucleic acids are the last type, the fourth type of organic molecule. Now these are different than the other three because we mentioned about them having energy. Nucleic acids we do not burn for fuel. We use them for a different purpose. These will have a combination of carbon, hydrogen, oxygen, nitrogen, and a little bit of phosphorus. Their function is these are the blueprints, the codes that code for making proteins. It holds the information for which amino acid comes first and second and third, fourth, etc. And it carries that genetic code from one generation to the next. How you know how to make hemoglobin is because your parents told you. You have their genetic makeup, half from mom, half from dad, and they tell you how to make these proteins. So it goes from one generation to the next. Like amino acids are made up of, well, proteins are made up of amino acids. Nucleic acids are part of units we call nucleotides. That's a nitrogenous base, that's the nucleic acid, a sugar, and then a phosphate. That makes a nucleotide, and then they're held together from phosphate to sugar in a backbone with the nucleic acid sticking out here on the one side, and this reads the information. This holds the information. This is a strand. Now a strand can be a single strand like shown here, or it can have its complementary image on the other side joined in the middle, a double strand. There are two types of nucleic acid strands. There's DNA and RNA. RNA because it has a ribose sugar as that sugar in the middle. DNA has a ribose sugar but missing an oxygen, so it's called deoxyribose, hence DNA. DNA is made up of the bases A, C, G, and T. RNA uses the bases A, C, G, and U. So one of the basic differences that you can readily see in a sequence, of course, is anything that has a T will be from DNA, and anything with U will be from RNA. DNA is very long because it contains all of your information, what we call the blueprint of life. Like a blueprint contains all the information for a building. It's long lasting because as long as you have that building, the only way you maintain it is by using the blueprint. If there's a hurricane, a tornado, something, and it damaged your building, you go back to the blueprint to repair it. To make that long lasting, because I mean somewhere in your body actually you might still have a strand of DNA left over or in there somewhere that you received upon conception, so it's as old as you are, theoretically. DNA is double strand. That's what makes it so sturdy, because we call it the ladder structure because it looks like a ladder. The backbones are on the sides, and the nucleic acids come together in the middle, kind of like the rung of the ladder. Now, because of hydrogen bonds, it actually twists a little bit, but it's still what we call ladder structure. And ladder is very, very sturdy. In fact, when I go visit my parents, my father, you'll see a bunch of stories during this semester of how cheap he is. And when he built his house, the guy says, well, we need some helpers. He says, no, I'll help you when I get off work. Okay, well, we need a couple ladders to start the house. And my dad went, hey, ladders are expensive. So he decided just to make his own. He grabbed some wood and some nails, and he made his own ladders. And yeah, the carpenter's like, yeah, he's pretty cheap. Okay. Well, not only did he make his house with that, he also built a garage and a barn. After a tornado, he rebuilt the garage. He tore down the barn, put a roof on, fixed the garage, put another roof on the house. And in fact, when I go back there, even like last summer, I'm 52 years old, and I'm climbing up this ladder cleaning his gutters, and the ladder is 53 years old. That is a stable, sturdy structure. Nature does the same thing. It's a good, sturdy structure, and nature uses it for this molecule to last you your lifetime. Now, RNA, though, it is short. It's what we call the photocopy. You don't need to make a whole copy of the blueprint to go make the staircase in a building. You just need that portion. So this will take a snapshot of just that portion of the blueprint it needs for today. It's temporary because things change over time. Most of the proteins you make in your lifetime are before you're born, some 3/4 of them. It'd be a waste to keep making those even though you don't need them. So you need a way to be able to change. If you need to remake this is temporary, it wears out. If you still need to make more, you go make more photocopy. You make more of the protein. If you don't need it, you change. It's single-stranded, and that's what makes it temporary. Imagine half a ladder. How stable is that? You might be able to shimmy it up and down a couple of times, but very shortly it's going to fall apart. It's not stable. But again, if nature wants something to be unstable, it makes it unstable. So you use it a few times, it falls apart. If you need to make more, you go make more. If not, you move on. The way we double or duplicate our blueprint is what we call replication. Okay, making a copy of your DNA. When you copy your RNA, well, when you make your RNA from your DNA, that's called transcription. There are 3 types of RNA. There's messenger RNA, abbreviated mRNA, and it's the one that actually carries the message of which amino acid comes first, second, third, fourth, fifth. There's ribosomal RNA, abbreviated rRNA. It's the foundation for making ribosomes, the factories where proteins are going to be made. And transfer RNA, tRNA, these are the ones that pick up and take the correct amino acid out of the 20 and puts it into the ribosome to be assembled in correct order.